This is topic 10.3, the nth term test for divergence. And here we have our infinite series. And as you can see, we have n equal 1 to infinity of a sub n, and we will be summing those terms up. So the sum of a sub n from n equal 1 to n equal to infinity. And here's some important facts about infinite series. If the series converges, then the limit as n approaches infinity of a sub n is equal to 0. So you don't see a series here. Just the limit of the terms is equal to 0. Another fact, if the limit as n approaches infinity of a sub n is equal to 0, then the series may either converge or diverge. And what's important to note is that this is not an if and only if. Okay? This is an if, then, and this is an if, then statement. Okay? That leads us to our nth term test for divergence. And it goes like this. If the limit as n approaches infinity of a sub n is not equal to 0, then the series a sub n diverges. So we will be looking at the limit of the terms of the series to see if the series diverges. Okay, let's go ahead and give this a try. Use the nth term test to make a conclusion about the divergence for each series. Let's take a look at number 1. We're given this series, and this is a sub n. Okay? So this is the series of a sub n. So we want to take the limit as n approaches infinity of a sub n and let's see what we get. As you can see, this limit is equal to 3/5. And 3/5 is not equal to 0. Therefore, the given series, or that series, diverges, and we have to say why, because we will have a lot of tests, by the nth term test. Okay, let's look at number 2. What do you recognize? You guessed it. We have a geometric series. Now, we're not really using what they told us to use. We're supposed to use the nth term test for divergence. But we are going to go ahead and note that this is a geometric series and proceed in this manner. And we also want to make sure you know that you must recognize the series. You must recognize geometric series, okay? So it's a geometric series with a equal to 3 and r equal to 1/2. Since the absolute value of r is less than 1, the series converges to its sum. So we already know that the series is convergent. Why don't we go ahead and find that sum? The sum is a over 1 minus r. 3 over 1 minus 1/2, and that's equal to 6. So we know that the series in number 2 converges, since it's a convergent geometric series. Moving on to number 3, this is a very special series. In fact, I'll go ahead and tell you the name. It's called the harmonic series. And you're going to learn pretty soon if the harmonic series converges or diverges. But before we do that, let's go ahead and use the nth term test for divergence. So we're going to take the limit. Remember, this is a sub n. We're going to take the limit as n approaches infinity of a sub n. And yes, it's 1 over infinity, which is 0. Now, therefore, the nth term test for divergence is inconclusive. So we are going to have to go find another test. So you can just say right now, we don't know if it is convergent or divergent. Moving on to number 4, let's go ahead and see what we have. Let's rewrite this. Get a better look at this. As you can see, this numerator is 2 to the n times 2 squared, all divided by 2 to the n times 2 cubed plus 1. And as you can see here, n equal 1 to infinity, we have 1/2 times, we just have 1/2 because all of the other terms, actually, let's just leave it like that, and then let's go ahead and do our limit. Find our limit, I mean. And then this will make sense. So this is a sub n, so we're going to find the limit as n approaches infinity of a sub n. So 2 to the n over 2 squared, 2 to the n over 2 cubed, plus 1. And remember, when we're finding the limit, this 1 is negligent. So then you can see we have 2 to the n canceling, and we end up with a 2 in the denominator. So this is actually equal to, let me move this down just a touch. And we end up with 1/2. And 1/2 is not equal to 0. Therefore, the series diverges by the nth term test. Okay. One more problem. Look at this series. We're going to go ahead and apply our divergence test. This is a sub n, and we're going to take the limit as n approaches infinity of e to the 4n divided by 3n. Now, as you can see, we have infinity over infinity, so we could apply L'Hopital's rule, and we would have 4e to the 4n divided by 3, and as you can see, that would leave e to the infinity in the numerator, and that's going to be infinity. And that is not equal to 0. Therefore, the series diverges by the nth term test for divergence. So the nth term test for divergence is really good if you can quickly see that a sub n the limit of a sub n is not going to be 0. So it's a really good test that you can quickly glance at a series. And this concludes this topic.